Okay, so we've been basically working with finding relationships between two variables. So we did, let me think what we've done. We've done with how much time it takes for you to get to a certain place. We've done graphs that showed how much it cost over a certain amount of time. And then the last time I saw you guys, we did the equations for pattern. So if we had a pattern where, for instance, we had 4, 6, 8, 10, 12, we worked out that the difference between these terms were a constant difference of 2. And I taught you guys that to work out the general formula for a pattern, you had to use Tn is equal to dn plus c, where d is your difference and c is your constant. Okay? And this n was your input values, and the Tn was your output values. So what you got out. So every time you put something in, this would be how much you got out, and it went through a certain process. So say, for example, I gave you guys the equation Tn is equal to 2n plus 3. Okay? And we said that basically what happens is these input values go through two different things. So if I've got my input values on this side and my output values on this side, then whatever I put in first gets multiplied by 2, so times by 2, and then gets added, 3 gets added. So for instance, if I put 1 into this equation, okay, as my input value, so my n, so it will be 1 times 2 gives me 2, plus 3 gives me 5. If I put 2 in, 2 times 2 gives me 4, plus 3 gives me 7. Okay? For instance, if I wanted a different input number, so I want to know what the 20th term will look like. So if I put 20 in, what will my output value be? So I say 20 times 2 gives me 40, plus 3 gives me 43. Okay? So this equation just summarizes this flow diagram. Okay? But we did learn this earlier last week. Alright, and it's the same thing as saying, I want to know what the first term will give me. So I put in 1, and I say 2 times 1 gives me 2, plus 3 gives me 5. Okay, same thing. If I want to know what the 10th term gives me, so I put in 10 into my equation, and let's see what I get out. So 2 times 10 gives me 20, plus 3 gives me 23. Okay. So this is just a little recap of what we did. Now if I take this equation, okay, and I put it into a table, so the whole point of this lesson is taking one of these aspects, so either a table, equation, or graph, and put it into the other two. So for instance, I've got my equation, I can put it into a table to also represent the relationship, okay? So if I have my input values at the top and my output values at the bottom. So I know that 1 gives me 5, I know 2 gives me 7, I know if I put 3 in, it will be 3 times 2 gives me 6, plus 3 gives me 9. If I put 4 in, then it gives me 11. If I put 5 in, then it gives me 13. Okay, so this now is my table format. So I've taken my equation and I've put it into a table format. Okay, now I can take my table and put it into a graph, or I could have taken my equation and put it into the graph. Okay, but let's do from table to graph quickly. So if I draw my graph, and you guys are going to draw a much better graph than me, and I put my output values. Your output values always go on your y-axis, okay? Your input values are always on your x-axis. So my output values, let's go up in 5. So I've got 5, 10, 20, 15, 20, and obviously there needs to be the same amount of distance, but I won't do that now. 30, okay? And then I've got my input value, so that's 1, 2, 3, 4, 5. So now I draw it. Okay? I know if I put in 1, it gave me 5. So I go 1, and my output value was 5. Okay? My input value is 2, and my output value is 7. So I can go like that. Okay? My input value is 3, and my output will be 9. So it's somewhere there. And then I go down to 3, so my line will look like that. If my input value is 4, I get 11, so my value will look like that, my point. If I put in 5, I get out 13, so that's about here. Okay, this isn't accurate, but you guys get the picture, and then I draw my graph. Okay. So that's now going from an equation to a table to a graph, and I could go the other way around. So I could read off my graph and say, okay, my input value is 1, then my output value is 5, and then I say input value is 1, output value is 5. So I can go from a graph to a table to a formula, okay, either way. So let's do some examples. Feel free to pause it whenever you want to. Okay, so if I do, this example is on page 120 in your books, okay, and it says ABC Plumbers charges 400 Rand call out fee and 60 Rand per hour. Okay, and then it says represent the relationship between number of hours and total cost. Okay, in a equation, table, and graph. Okay, so now I read carefully, and I know for every single call it will be a 400 Rand call out fee. So that means no matter how long they've worked, their call out fee, so to get there, is 400 Rand. Okay, and then it charges 60 Rand per hour. So there's two things that are happening. Okay, so first of all, your amount of hours, the number of hours, gets times by 60, because I want to know if I work for 2 hours times by 60, that means 120 Rand. But another thing happens. Every single call out fee, so no matter what, is 400. So I add 400 to that. Okay, so I've done my rate, so 60 Rand per hour. So I know if there's 3 hours times 60, that's 180 Rand. And I add the call out fee of 400 Rand every single time. So do you agree that I can write this as Tn is equal to 60N plus 400? Because if I look at it and I draw it in a flow diagram, Okay, the first thing that happens is I times the number of hours by 60. The second thing that happens is I add 400 to it because that's a standard call out rate. So if I put in 1, I get out, so 1 times 60 is 60 plus 400 is 460. Okay, if I put in 2 hours, 2 times 60 is 120 plus 400, which gives me 520. Okay, 3, so if I do 3 times 60 gives me 180 plus 400, that gives me 580. Okay, let me know in the comments if you don't understand what I just did here. Okay, so now I'm going to write it, I've written it as an equation. So my first part of my question is done. Then my table, so I draw my table. Okay, input values at the top, output values at the bottom. So it will be number of hours as my input and the total cost as my output. So now I've got for 1 hour, 2 hours, 3 hours, 4 hours. So 2, 3, 4, 5, 6. Okay, you can do as little as many. Sometimes they give you the table so then you know exactly how many to do. So 1 I said gives me 460. 2 gives me 520. 3 gives me 580. And 4 gives me 640. Okay, so now I look and I put this into a graph. So remember what I said, your input values are always on the x-axis, output values are always on the y-axis. So my input is 1, 2, 3, 4, 5. Okay, I've skipped 5 and 6 just so that we can do little by little. Okay, so I'll go up in 50s. So 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550. Okay. Wait, sorry, this isn't going to work. So we'll keep that. Let's just draw a different graph because I need more space. Okay, so it will be 1, 2, 3, 4, 5. Y is, I'm going to do it in hundreds. So 100, 200, 300, 400, and then 500 and 600. Okay, so this is an excellent example. If you draw a graph and you see that this isn't big enough, you can always change it. Just redo it. Okay, so I said for my 1 hour, I get paid 60 Rand an hour, so I say 60 times 1 plus 400, but I can get this all from my table. So 1 will give me 460, so that's about, 460 is about here. Okay, going down, that's 1 hour, so I put my little mark there. Okay, 2, 520, so that's about there. So 2 hours gives me 520 Rand. 3 hours gives me 580, so that's about there. Okay, and 3. All right. Now what's important to understand is my graph can't just start there. Okay, if I work 0 hours, what do I get? So I say 0 times 60, okay, 0 plus 400, so that gives me 400. So I start at 400, okay, and that's what my graph looks like. So I've represented it in an equation. I've represented it into a table, and I've represented it into a graph. Okay, so I want you to do the activity that's linked on the folder and send it back to me.